The engine which we see here is a single shaft turbojet engine. It is the Viper jet engine manufactured by Armstrong Siddeley in the 1950s, 1960s. Later it has been also manufactured by Siddeley Bristol as well as Rolls-Royce, and it has been in operation until 2011. So when we look at the overall setup of this engine, again it is a single shaft engine. The air is entering from the left here at the inlet of the engine, thereafter passing through the compressor, through the combustion chamber, and then through the turbine. When we take a closer look now at the compressor, go a little bit closer here. First of all, we see the set of compressor blades. It consists of rotating blades. This is the rotor. I make it rotate here. As well as a set of stationary blades. You see them in here integrated in the casing. Very typical for these blades are that these are little curved. We see the sharp leading edge, the specific or characteristic compressor profile, as well as the sharp trailing edge. You also see that the blade height decreases as you go from the inlet of the compressor to the outlet. Now let's take a closer look at the combustion chamber. After the compressor, the air is entering the combustion chamber, and I see directly here that the flow is separated into three portions, one of which, the center here, is going into the combustors and then into the combustion chamber. The other two portions go around the combustor and enter here the combustor at a certain distance downstream of the flame, such as to cool the combustor walls. This applies for the outer wall of the combustor as well as for the inner wall of the combustor, where you can see these rectangular slots where the air comes out. The combustion chamber is of an annular type, which means that we do not have cans. Instead we do have a continuous ring in which the combustion is taking place. And what we see here is a cap of a combustor. We have 24 of these flame holders, so to say, in the combustion chamber. Now let's take a look at the turbine. The turbine here is also an axial type of turbine, as was the compressor, an axial type of compressor. It consists of a single stage turbine, where we see here again the rotating blades. This is the rotor. Make it move for you. As well as then upstream of the rotor, the stationary blades, these here. Now the turbine, of course, is used here for driving the compressor. Downstream of the turbine, the portion down here is called the exhaust casing. It is used to accelerate the flow, as well as here you have a number of outlet guide vanes. These are these struts here, which are used to direct the flow, such as that the flow out from the engine has an axial direction. The overall properties of these engines is that we have a pressure ratio of around 4.3. At a nominal speed of around 13,000 RPM, this engine would have produced a thrust of 12 kilonewton.